Okay, today we're talking about the law of of cosines today, uh, which I have here on the slide. They look a little bit more complicated than the law of sines, but the nice part about them, of course, is they have no ambiguous case. So let's say I have a little triangle here. I'll label this side alpha, which means that angle alpha, that side's A. I'll label this angle beta, so the side opposite there is B, and I'll label this side gamma, so the side opposite that is C. Now, all they're really saying here, and these formulas look complicated, but remember they're on your formula sheet, but all they're really saying is that if I want to find, let's say, side C, what I need to know is the other two sides, B and A, and of course the angle in between them. Right. All right, let's look at an example. So here we go. I've got my example. C is 7.9, A is 9.6 units, and angle beta is 52 degrees. So let's draw ourselves out a nice little triangle here. In my triangle, I've got this angle up here. That's 52 degrees. Let's see. I'll call this angle down here. I'll call that angle alpha, which means this side opposite is going to be 9.6 units. I'll call this angle here lambda, which means the side opposite there is going to be 7.9. So let's see, if I want to find the side B, well, I remember that B squared, because of this law of cosines, B squared is equal to 9.6 squared plus 7.9 squared minus 2 times 9.6 times 7.9 times the cosine of the angle in between them, which is the 52 degrees. Well, frankly, I'm just going to put this into my calculator. And once I put all that into my calculator, I get 61.8646742742, I think is what I have in my calculator as I'm looking at it. Then I'll take the square root of both sides, so B is equal to 7.82217791, so we'll round that off to 1/10 and say side B is about 7.8 units. So I now know what side B is. In order to solve this triangle, I need to find the other two angles, though. Now, I can find the other two angles either with the law of cosines or, well, frankly, I could solve it with the law of sines now that I know one of these guys. So let's do this. I can take the sine of alpha over that side, 9.6, the side opposite alpha, is equal to the sine of angle beta, which is 52 degrees, divided by the length of the side, B, which we just said was 7.8. And then again, I'm going to use my cross multiplication to figure this out. So I'll say sine alpha is equal to 9.6 times the sine of 52 degrees, all divided by 7.8. Now when I pop that into my calculator, I get sine of alpha should be equal to, well, it's going to be equal to 0.9698593,821, I think is what I get. So alpha itself should be the sine inverse of that same number, 0.9698593,821. Let's put parentheses there. So alpha, the angle alpha, should be equal to well, on mine it's 75.89 something something something, so we'll say alpha, round to the nearest tenth, is 75.9 degrees. And then to find gamma, we'll just say gamma is equal to 180 minus the 52 degrees for beta that we were given, minus the 75.9 degrees that we just got for alpha. So gamma is going to be equal to 52.1 degrees. So now I've got gamma and alpha. We were given beta. I found side B, so I have now solved this triangle using the law of cosines. Alrighty.